a bolt of lightning on Jupiter. Not a storm, one bolt. Scientists just measured it. And it could carry 1,000,000 times. You're listening to Stardrift FM. Tonight, NASA just rewrote its entire space program. Jupiter storms are hiding something we weren't prepared for. A brand new telescope measured the speed of a galactic wind for the very first time. 2 space telescopes combined to show us Saturn like we've never seen it. A moon knocked its own planet sideways over billions of years. And in 6 days, 4 humans leave Earth for the moon. Grab your coffee, let's get into it. 2 days ago, NASA Administrator Jared Isaacman walked into a press conference and essentially said, "We're starting over." The event was called Ignition, and it lived up to the name. First headline, NASA is building a permanent base on the moon. Not a temporary outpost, a permanent settlement. $20 billion over 7 years, 76 separate landings delivering over 200 metric tons of hardware. Habitats, nuclear power systems, rovers, drones, in situ manufacturing equipment. The plan runs in 3 phases through 2036, with human crews living there long-term beginning around 2032. And to build this, NASA is scrapping the Lunar Gateway, the planned orbital space station that was supposed to be the staging point for all of this. Gone. Canceled. They're going direct to the surface instead. Apollo style but permanent. Second headline, and this one might be bigger in the long run. NASA is sending a nuclear-powered spacecraft to Mars. Before the end of 2028, it's called Space Reactor 1 Freedom, SR-1 Freedom, the first interplanetary spacecraft in history to use nuclear electric propulsion. When it gets to Mars, it will release a payload of small helicopters called Skyfall to continue the aerial exploration that Ingenuity started. Nuclear propulsion for deep space has been a goal since the 1960s. Nerve in the Apollo era, canceled 1972. Project Prometheus in 2030, canceled 2005. This is the first time it's actually going to fly somewhere. Isaacman's line at the press conference, "The moon is not a destination, it's a proving ground." All right, back to that cold open. Researcher Michael Long at UC Berkeley Space Sciences Laboratory has been going through data from NASA's Juno spacecraft, which has been orbiting Jupiter since 2016. Specifically data from 2021 and 2022 during what they're calling stealth superstorms. Convective events that form deep beneath Jupiter's cloud layers and are essentially invisible from above. Invisible to the eye, not invisible to Juno's microwave radiometer. Juno detected 613 individual microwave pulses from lightning during those storm passes. On 4 close flybys, it was near enough to measure the actual power of individual bolts. The range from something roughly equivalent to a bolt here on Earth, all the way up to 100 times more powerful. That's the confirmed measurement. The theoretical upper bound, based on how lightning radiates energy, puts it at 1,000,000 times Earth's lightning. Why is it so powerful? Jupiter's atmosphere is mostly hydrogen. Hydrogen is heavier than nitrogen, Earth's main atmospheric gas. To push moisture-laden clouds upward through hydrogen, you need massively more energy. The storm columns go deeper, build up more charge, and when they discharge, you get this. On one single flyover, Juno counted 206 separate pulses, 3 flashes per second. Storms you cannot even see from orbit. Here's a question that's been open for decades. Galaxies that are forming stars at enormous rates, starburst galaxies, produce massive outflows of gas that stream out above and below the disk. We can see the outflow, we photographed it, but nobody could measure how fast the hot core of that wind was actually moving. Until this week. The galaxy is Messier 82, the Cigar Galaxy, about 12 million light-years away in Ursa Major. It's forming stars 10 times faster than the Milky Way, and it has this famous Galactic-scale outflow visible in long-exposure images, red gas plumes blasting out in both directions. The telescope is XRISM X-ray Imaging and Spectroscopy Mission, a joint NASA and JAXA mission launched in 2023. Its Resolve instrument is the most sensitive X-ray spectrometer ever put into orbit. What XRISM did, it looked at the X-ray signal from superheated iron atoms in the galactic core. Iron emits at a very precise X-ray wavelength. By measuring how much that wavelength was shifted, Doppler shift, lead author Aaron Bocher's team could calculate the exact speed of the gas, 2 million miles per hour, at a temperature of 45 million degrees Fahrenheit. And the gas is moving fast enough, more than fast enough to drive the entire large-scale outflow all the way to the edge of the galaxy. The hot inner wind is the engine. The red plumes you see in photographs, those are the exhaust. Published in Nature, March 25th. Title: A fast starburst wind consumes most of the energy from supernovae. It does. This one is for the people who just want to look at something beautiful. NASA released this earlier this week, a combined view of Saturn from both the James Webb Space Telescope and Hubble. Webb observed in November 2024. Hubble observed the previous August. Both images released together. And together they are the most comprehensive view of Saturn we have ever assembled. Here's what makes the combination useful. The two telescopes see completely different things. Hubble invisible light shows you subtle color variations in the cloud bands, chemistry differences at cloud top level. Webb, in near-infrared, penetrates the atmosphere at multiple depths simultaneously. You can slice through Saturn's atmosphere like an onion, layer by layer, from the deep cloud decks all the way to the upper haze. In Webb's image, there's a long wavy structure across the northern mid-latitudes, the ribbon wave, a jet stream that's been active for decades, driven by atmospheric waves that are otherwise invisible. Just below that, a small spot. That's the remnant of the great springtime storm of 2010 to 2012. A storm so large it wrapped all the way around Saturn's entire circumference, still visible 14 years later as a faint scar. Several moons are visible in the same frame: Janus, Dione, and Enceladus, the one with a subsurface ocean and geysers, all just hanging there alongside the rings. Saturn's rings are also in a transitional moment. 1 year ago, the ring plane was edge-on from Earth, and the rings were almost invisible. They're tilting back now, and these images caught Saturn right in that transition, the rings thin and elegant, the planet fully framed. Neptune has a 28-degree axial tilt, similar to Earth, and for decades nobody could explain it. For Earth, the tilt makes sense, a giant impact early in solar system history. Same with Uranus, which is tilted 98 degrees practically on its side, also an ancient collision. But Neptune, there's no obvious impactor, no clear culprit. The tilt just sits there. A new preprint from Rodney Gomes at the Observatório Nacional in Rio de Janeiro proposes an answer, and it doesn't require any collision at all. The answer is Triton. Triton is Neptune's largest moon, and it is deeply strange. It's the only large moon in the solar system that orbits its planet backwards, retrograde, against Neptune's rotation. It almost certainly didn't form around Neptune. It was captured from the Kuiper Belt, a dwarf planet-class object that wandered too close and got pulled in. At capture, Triton had a wild, eccentric, inclined orbit. Over billions of years, tidal friction between Triton and Neptune gradually circularized that orbit. The same process that causes tides on Earth to slowly push our moon further away, just reversed. As Triton's orbit evolved, Gomez's model shows it entered resonance with the long-period oscillation of the solar system called XEP, a wobble in the overall geometry of the planet's orbital planes driven by all their mutual gravitational pulls. That resonance acted like a hand nudging a spinning top. It wrought Neptune's axis slowly over billions of years to 28 degrees. 1 in 4 simulations produces a tilt greater than 20 degrees. Some go past 50. Neptune's 28 fits easily within that range. A moon, captured from the outer solar system, that then spent billions of years quietly tilting the planet it lives around. There's something almost patient about that. 6 days. April 1st, 6:24 in the evening Eastern Time. That's when 4 people are scheduled to leave Earth and travel to the moon. for the first time since Apollo 17, December 1972, 54 years ago. The crew, Reed Wiseman, commander, Victor Glover, pilot, Christina Koch and Jeremy Hansen, mission specialists. Hansen becomes the first Canadian to fly to the moon. Tomorrow, March 27th, the crew flies from Houston to Kennedy Space Center. They've been in quarantine since March 18th. The rocket has been at Pad 39B since March 20th. No technical issues. Everything is ready. The mission is 10 days, no landing. This is the shakeout flight, Orion and SLS carrying a full crew for the first time. The trajectory is a free return arc around the far side of the moon. Free return means even if the engine fails, the spacecraft loops around and comes home on its own. Same safety concept Apollo used. The farthest point, about 280,000 miles from Earth, farther than any humans have ever been, breaking Apollo 13's record of 248,000 miles set in 1970. The crew will pass completely behind the moon, total communications blackout, alone further from Earth than any human beings in history. There's something about knowing this is 6 days away. The rocket is already on the pad. The crew is already in quarantine. The countdown is already running. 54 years is a long time to wait. That's Stardrift FM for March 26, 2026. Tonight, NASA is building a permanent moon base and sending a nuclear spacecraft to Mars. Jupiter's lightning can be 1,000,000 times more powerful than ours. We finally clocked a galactic wind at 2 million miles per hour. Saturn never looked like this before. A captured moon spent billions of years tilting Neptune sideways. And in 6 days, humans go back to the moon. Thanks for tuning in. This is Stardrift FM.